In this case, we will be predicting MLB game attendance. So, for our model, we used cat boost gradient boosting to engineer a dynamic model that has the capacity to react to real-time data and predict MLB game attendance. Our agenda for today is that firstly, we'll be going over some influential features. Next, we'll do some data processing and cleansing. Third, we'll talk about our predictive model and compare the different types of models that we included in our analysis. And lastly, we'll be giving some business insights for the Minnesota Twins. Over here, we have the distribution for MLB game attendance. As we can see, Minnesota is pretty similar to other MLB teams, but we can see that Minnesota, the values mostly lie between 10,000 to 40,000 range, and the distribution is quite similar. However, for Minnesota, there are certain factors that cause a difference in the distribution, and that will be better explained by Xiaoyu in the next slides.
Thank you, Gary. I'm Xiaoyu. I'm talking about the influential feature in our models. So our cables have ability to identify the feature importance and quantify of the score of those. We rank them our feature, and we find out that the media attendance 2 years ago and the medium attendance 1 year ago is two of the most important features in our models. Following by that, the time series data such as the day of a week, day of a year, and the year. Our model have ability to identify the feature importance of the feature. So based on those value, we rank our feature from the importance value from high to low. So the most important feature is the previous year attendance, include 1 year and 2 years ago. We use the median value to exclude the outlier. And the second is time series data, such as the day of week, day of year. And then following by is the team information, such as the team, the name of the team, the league of team, and the last year final ranking of the team. So let's go into the top factor influencing the home game attendance. So it's showing graph. The x-axis is the average attendance of previous year, and the y-axis is the average attendance of the current year. And each data point represents the attendance of the average attendance of the previous year by a fixed x interval. So a showing graph, the whole data point line pretty close to the 45-degree line, which is a red line in the graph, demonstrate that the previous year average attendance have a high positive correlation with the current year average attendance. And unsurprisingly, day of week have take a significant role in there, because since people have more leisure times in the Friday, Saturday, and Sunday, so the average attendance is higher in those days. But things become too interesting if we consider the final year's rank. The x-axis is the visiting team ranking. The lower the value represent the team are stronger, and the y-axis is the Minnesota Twins average year's attendance. So through the graph, we can observe that the fan of the Minnesota Twins are more likely to attend the game when the Minnesota Twins are compared with the relative weak team. So which is actually fits our intuition that the people are more likely to go to the match when the team they support have more chance for winning. And now next, Gary will talk about data preprocessing.
Moving on to the data preparation and sources. So we have three main sources of data, including retro sheets, open media, which is a weather API, and baseball reference. So in addition to the provided data set, we scraped data from all these three sources and combined them, and we merged them based on a join, and we joined on date, home team, and visiting team. So this scraping allowed us to get an initial data set of 160 features. And moving on, we're going to now talk about the data pre-processing. So with our now new 160 features, we just cleaned stuff, like we handled the NaN values, changed the categorical variables to numerical variables, and corrected team names. And after the final pre-processing, we also calculated the average attendance for the past 3 years, and our final data set had 200 plus features. Now, we'll be moving on to the predictive model.
Let's move on to the predictive model. As a brief overview of what models we tested, let's provide a graph that describes our model performances. As reference, we use mean absolute error for a metric, and lower is better in this case. So as a preface, we used baseline models such as linear regression and decision tree for regression, and we found that they weren't able to interact with the complexity of our features and the complexity of the problem of predicting MLB attendance. So we decided to take on the route of using more robust models, such as random forest regressors, XGBoost, and neural networks for embedding, which is a deep learning technique, as well as CatBoost, which we arrived on to give the best mean absolute error. In this case, our model achieved a mean absolute error of around 3,400 on the holdout test set. Moving on to the next slide, I wanted to briefly describe how our model performs the way and kind of gain insight into the interpretability aspect. So our model works by deciding a split point on our data set features and grouping similar features together in that way. So you can imagine if we had the previous year's attendance, we determine a split point based off of the certain threshold, and from there we could be able to determine a split that would guarantee or minimize the error, in our case, which is mean absolute error. Moving on to the bonus element, we created a dynamic prediction model that is adaptable and can update to real time and, most importantly, continuously improve upon predictions. One way we do this is through the capabilities of gradient boosting, specifically in CatBoost. And so the mechanism itself allows us to emphasize misclassified samples more, and in this iteratively improve the training process, and as a result leading to better test results. And we also were able to improve our dynamic predictions by utilizing factors such as weather, current record, player performance, and we were able to gather this data through web scraping various sources.
Thank you, Alex. So we've talked a lot about the technical aspects of our model, and a lot about what went into the model in terms of data and the model itself. So now we're going to talk a little bit about how this can actually help the Minnesota Twins as a business. So firstly, the graph you see is the monthly median attendance of Minnesota versus other teams. So we can clearly see from this graph that on average, Minnesota has lower attendance than other teams, and this is really the problem that we're trying to solve using our model. So over here, we can see a graph of our predicted attendance versus the observed attendance in previous years. We used our model to predict 2022 attendance and compared that to the observed attendance, and we get this scatter plot, which really moves around this 45-degree line, which really does show a strong correlation between our predicted attendance and the actual observed attendance at that time. How this can actually help the Minnesota Twins. So over here we see a graph that shows the error given by a linear regression in blue and our CatBoost model in orange. And we can see that overall our CatBoost model has much less error compared to a basic linear regression model. And how that helps in terms of operations is it's much easier to plan for concessions. For staffing, it's much easier to prevent overcrowding in certain areas. From a finance perspective, it's overall easier to control costs. You know predicted attendance, or you have a stronger prediction of attendance for games. So we also used our model to get an estimate of our 2022 revenue. So how we did this was we took the average ticket price in 2022 and we took the number of home games, and then we used our model to predict our average attendance in 2022 to find a predicted revenue by our model. We did the same to find a predicted revenue by linear regression, and then we found the actual estimated revenue by looking at the actual observed attendance, or average actual observed attendance in 2022. And comparing the three, we can see that the predicted revenue by our CatBoost model is very similar to the actual estimated revenue, whereas the predicted revenue by linear regression is off by almost $10 million. So lastly, in terms of marketing, we identified that past attendance is one of the most influential factors influencing attendance. We also noticed from secondary data that most MLB ticket sales are actually done in the off season and not in the future season. So we think that this could be a potential aspect that the MinneMUDAC Twins could target in terms of implementing marketing strategies in the off season to kind of counteract this potential negative attendance that they could receive from having a poor performance in previous years.
So, to summarize, to predict the MLB home game attendance, we developed a model using cat boost gradient boosting method, and this model shows a greater predictive power over other models such as linear regressions model, random forest, neural network, and we are confident to say that we were able to identify several ways in which a more accurate forecast of attendance can help the Minnesota make better business decisions. And we believe that by implementing our model, the client's Minnesota Twins can reduce risk and can improve the planning and preparations process. And that is our summarize for this presentation. Thank you for your attendance, or for your attention.